What are the states of the three ideal diodes of the circuit shown in figure? It was the question asked in GATE 2020 instrumentation paper. Okay, see this. If you observe the diode D3, which is connected parallel to the current source, what should be the polarities of the current source? We can take plus minus. Means the cathode of the diode is connected to positive terminal and anode of the diode D3 is connected to negative terminal. So definitely D3 is off. What about D1, D2? Let me connect this one to ground. Anyway, the bottom line is ground. Then anodes of D1 and D2 are at the same potential. Then the diode with lowest cathode voltage only conducts. Cathode of D2 is going towards the positive terminal of the supply, whereas cathode of D1 is going to ground. So definitely D1 conducts and D2 does not conduct. A very simple point. So the diodes that are conducting means only D1 and D2, D3 are off. Option A is correct. Okay, just as an extension. If they ask us to find the current through the diode D1 or current through D1, D2, D3, we can understand current through D2 as well as D3 are 0. Okay, how to find the current through D1? Take the equivalent circuit. Here D1 is acting as short circuit and D2 is open circuit. D3 is also open circuit and the current source of 5 amperes. 1 ohm, 1 ohm, 1 ohm. This current is ID1, 10 volts. We can go with a nodal analysis, or first we can look at the source transformation here. Okay, so okay, source transformation. Further, what we can write? Ten volts, 1 ohm, ID1, 1 ohm, 1 ohm in series with a voltage source of 5 volts. This is how we can write. And it is ground. Let me take this current. Let me define two currents. This current I1 and this current I2. So that ID1 is equal to I1 plus I2. What is I1? Or I can write the node equation also, not a big deal. Okay. 10 minus 0. Here, what will be the voltage? 0. So, or I am directly taking the node equation. Let me take this as ID1 is equal to I1 plus I2. I1 is 10 minus 0 by 1 and I2 is 5 minus 0 by 2. It is 12.5 amperes. That's it. This is how we can take the value of ID1. 12.5 ampere. Okay, ID2 and ID3 are simply zeros. Next, look at this question. Find ZAB impedance looking into the terminals AB if the diodes D1 and D2 are ideal. Okay. So generally for finding the impedance, what we do in networks, we connect a source voltage by the current coming out of the source gives us the impedance looking from the source. Okay, so how do we find it? Anyway, as far as this circuit is concerned, there is no possibility for D2 to conduct because its cathode is going towards the positive terminal and anode is going towards the negative terminal of the supply. D2 is off and D1 acts as short circuit. So D1 is on and D2 is off. So what is the equivalent circuit? 10 volts. DT is open. Even I need not show that. Okay, 5K and D1 acts as short circuit. 10 kilo. I can even remove this 5K. It doesn't play any role. So that our equivalent circuit terminals AB 10K, 10 volts. So the impedance looking into the two terminals is 10 kilo ohms. That's it. A very simple question it is. Okay. Next, if you observe the diode characteristics, what we understood is if you take a diode, when right its characteristics means the original characteristics are something like this. Once the diode is forward biased, means if the supply voltage is greater than the cut-in voltage of the diode starts conducting and the current goes exponentially. And in reverse bias, almost negligible current will flow, which is in the order of nano or pico amperes before the breakdown. Okay, we know that. So for that, what we did, we developed different models. Like in forward bias, ideal diode short circuit. So the characteristics are something like this. Otherwise, the second characteristic is like an ideal voltage source. And the third model is we have seen all these things with slope. It is V gamma. Okay, as far as an ordinary diode is concerned. Now, if I take a GNR diode, what is the symbol of GNR diode? Z. GNR symbol. GNR diode. Okay. Again, how does it behave? What are its characteristics? If you take the characteristics of a GNR diode, in forward bias, the characteristics are same as that of ordinary diode. Exponentially rising function. Whereas in reverse bias, before breakdown, almost negligible current, zero current. And once the diode undergoes breakdown, constant voltage, it maintains a constant voltage of Vz and different currents will be flowing. Means it behaves like a voltage source of value Vz. Okay, we know that. So based on this, what are these are the original characteristics, I can say. Okay, whereas the approximate characteristics. So these are the approximate models, I can say. Here, What are the approximate models for GNR diode? One is like this. V gamma, and it is VZ. What is the meaning of these characteristics? In forward bias, it is a forward bias. So means when a GNR diode is forward biased, means anode is connected to positive terminal of the supply and cathode is connected to negative terminal of the supply. Then if the supply voltage is greater than the minimum or cut-in voltage, then there is a current flow, I can say. And voltage across the GNR diode is something like V gamma. That is from anode to cathode. Current flows from higher potential to lower potential. Anyway, that is as far as the GNR diode is concerned, current flows from anode to cathode. Anode to cathode current, it is positive, and the right anode to cathode current is positive, and the voltage across the diode is also positive. That's the meaning. So what we can write, its equivalent is like a voltage source of value V gamma. In forward bias, this is what we can observe. Whereas in reverse bias, means the circuit is something like this. I'm not changing the direction of the GNR diode. Reverse bias is possible with change of polarities of the input supply. Ah. Then what happens? If V input is less than its breakdown voltage, GNR diode acts as open circuit. So that this is the equivalent circuit. If V input is greater than the breakdown voltage, then GNR diode undergoes breakdown. So that the equivalent circuit is or I can say the current will flow from cathode to anode or the supply voltage. It starts conducting in the reverse direction. So the direction of the current flow is like this. I can say IZ. Current always flows from positive to negative terminal of the supply. We are well aware of it. And what about the voltage across the GNR diode? It is negative Vz from cathode to anode. If you see from anode to cathode, it is negative, whereas if you see from cathode to anode, it is positive. So voltage across the GNR diode is Vz from cathode to anode, and the current direction always positive to negative terminal. So Iz. Iz is flowing from cathode to anode. We can say. Okay. So, and this can be further written like polarities of the voltage source will be something like this. Vz, this current is Iz, R, and input voltage like this. Okay, the important points to be observed here is in forward bias, voltage from anode to cathode is positive and the current flows from anode to cathode. Or I can write voltage and current from. A voltage from anode to cathode of Zener diode is positive and current flows from or current from anode to cathode is positive. Okay, in reverse bias exactly opposite. Means in reverse bias voltage from oh, correct only. Anode to cathode, sorry, cathode to anode I can say opposite, no? Cathode to anode is positive and current, right? Voltage and current I can write, okay, no issues. And current from cathode to anode is also positive. That's the meaning of it. Just two different, so for voltage sources you can see. Anode to cathode, forward bias anode to cathode, the voltage is shown to be positive. And the current from anode to cathode is considered to be positive. Whereas in reverse bias, cathode to anode voltage is positive and current from cathode to anode is taken as positive. That is all. That's very, very important point of observation as far as GNR diode is concerned. Okay, just keeping, once you are good in understanding these points, then we can easily solve the problems based on this GNR diode. Okay, ordinary diode and GNR diode. See, GNR diode, its characteristics, how it's working, all those things cannot be discussed at this stage because it's application oriented. Right, in electronic devices and circuits, you can see all those, what is meant by GNR breakdown, avalanche breakdown, and how the characteristics have come, all those things. Here we deal with the application part. Okay, next. Based on this, let us see some problems. Yes, look at this question. The output voltage VO in the circuit shown in the given figure is, assume cut-in voltage of each diode to be 0.6 volts. Okay, cut-in voltage is given and two Zener diodes are connected back to back. Okay, and their breakdown voltage is 6.3 volts. How do we do this problem? First of all, look at the input. Is it greater than the breakdown voltage of Zener diode or not? Absolutely, it is greater. Then fine. Next, look at the diode D1. Its anode is connected to positive terminal and its cathode is going towards the negative terminal of the supply. It is behaving like ordinary diode. So simply forward bias. Forward bias means it acts like a voltage source of value V gamma, that is 0.6 volts. And look at the diode D2. Its cathode is going towards the positive terminal of the supply and anode is going towards the negative terminal of the supply. So it is under a reverse bias. Okay. Reverse bias with input greater than Vz. What is our Vz? It is a 6.3 volts breakdown voltage. So D2 is under breakdown, GNR breakdown implies. So GNR diode D2 is under GNR breakdown. I can write it. Okay. So what is the equivalent circuit then? If I redraw the things, instead of first one, I can write V gamma from anode to cathode 0.6 volts. And second one, from cathode to anode, I should write a voltage source. So here D1 anode to cathode, we can write it anode to cathode. And D2 from cathode to anode, I should take a voltage source of value 6.3 volts. That's it. 13 volts is our input. Okay, in D1, the current is flowing from anode to cathode, and in D2, the current is flowing from cathode to anode. Everything is fine. What about the total output voltage, friends? 0.6 plus 6.3, it is a 6.9 volt. A very, very simple thing. One diode is forward biased, another is under breakdown. And just anode to cathode, V gamma, I wrote it for as far as D1 is concerned, and cathode to anode, I wrote Vz as far as D2 is concerned. Ultimately, the output is 6.9 volts. Option C is correct. Okay, that's it. This is how we can do this problem. Next, look at this question. A 40 volts DC supply is connected across the network comprising of GNR and silicon diodes as shown. The regulated voltages VO1, VO2 and the source current IS respectively are. Okay, it was a question asked in engineering services. It's a simple one only. And now look at the diodes. Let me take these diodes as D1, D2 and D3. What about D1? Its cathode is going towards the positive terminal of the supply and anode is going towards the negative terminal of the supply. It is reverse biased. And its breakdown voltage is 6 volts, supply is 4 volts. So it looks like D1 undergoes GNR breakdown. D2. As far as D2 is concerned, its anode is going to positive terminal of the supply, cathode is going to negative terminal of the supply. It is simply forward biased. And D3, its cathode is going towards positive terminal of the supply and anode is going towards the negative terminal of the supply. It is reverse biased. And its supply, its breakdown voltage is 3.3 volts, supply is 40 volts. So it is also under GNR breakdown. Okay. Now, what is the equivalent circuit of each of these diodes? See this. Cathode to anode, I am writing a voltage source of value 6 volts as far as D1 is concerned. And D2, simply a voltage source of value V gamma is equal to 0.7. Here nothing is mentioned, but We'll see that. 0.6 volts, right, I'm writing. And the third one, let me write 0.7. Default value we take 0.7 volts only. If they mention, then valid. Next, coming to the third one, it is for D2. D3, it undergoes breakdown. So from cathode to anode, it is 3.3 volts and input is 40 volts. So what about VO1 and VO2? VO1 means after the ordinary diode, it is VO1. What is its value? It is 4 volts, 3.3 plus 0.7. Okay, here itself we can understand that option D might be correct, VO1. Okay, what about VO2? It is 6 plus 4, 10 volts. This resistor is 1.5K. Then what about the current in the circuit? I. I is equal to here the voltage is 40 volts with respect to ground. Here the voltage is 10 with respect to ground. 40 minus 10 by 1.5K. Okay. So how much we get? It comes around 15 by 30. Okay, 20 milliampere. 44 volts, 10 volts, 20 milliampere. Absolutely, we have got. It's a very, very simple. Okay, if you understand the equivalent circuit from the characteristics, just execute that. Later, it is just about networks only. Okay, like this, we can do this problem. Next series. Determine the values of V1, V2, V3, and V4 in the figure shown below. Now, if you see, 20 volts is the power supply. Let me take D1, D2, D3, D4. D1, right, its breakdown voltage is 2.4 volts, supply is 20. It looks like D1 is under breakdown. D2 is, its anode is going to positive terminal, cathode is going to negative terminal of the supply. D2 is forward biased. D3 is also same, forward biased. D4 is also undergoing breakdown because its breakdown voltage is 10 and supply voltage is 20. Okay. So if you take it, it is breakdown, forward biased, forward biased, again breakdown. So what we can write? For the sake of students, I'm writing these many, but just like that, by looking at the circuit, you can write the answer. Just adding all those things, right? It is 2.4 volt, zero point 0.7 volt, 0.7 volt. So it is 10 volts. It is mentioned as V4, it is 10 volts. It is mentioned as V3, whose value is 10.7 volt. Next, V2, it is equal to 10.7 plus 0.7, 11.4 volt, and 11.4 plus 2.4, it is equal to 13.8 Faraday. So option 8, 13.8. That's it. Some resistor R is connected. If R is known, then you can find the current through the diodes. So very simple. Now look at this question. Assuming Zener diode D1 has the cut-in voltage, current voltage characteristics as shown below. On the right hand, forward voltage drop of D2 is 0.7 volts. The voltage VO in the circuit shown below is one Zener diode and one ordinary diode are kept in this. And they are asking us to find the output voltage. Okay, so what is the meaning of it? As far as D1 is concerned, V gamma of D1, it is 0.7 volt. Means if D1 is forward biased, voltage across it is 0.7, and if D2 is under, D1 is under breakdown, then its voltage from cathode to anode, it is 2.7. Anode to cathode minus 2.7 volts. From cathode to anode, it is plus 2.7 volts. That's the meaning of it. Okay. Then look at the supply voltage. It looks like the supply voltage is greater than the breakdown voltage of diode D1. Breakdown voltage is 2.7. It looks like D1 is under Zener breakdown. What about D2? Anode is going towards the positive terminal, cathode is going towards the negative terminal of the supply. D2 is forward biased. Okay, it looks like. So assume D1 is under breakdown and D2 is forward biased. Okay. If so, what we can write for D2? Okay, I'm just showing it by means of its VZ, whose value is 2.7 from cathode to anode. It is a 3.75 volt, and D1 is forward biased, voltage across it is 0.7 volts, 1 kilo ohm and 1 kilo ohm output. So it looks like our output is equal to VZ, that is 2.7 volt. But don't be happy with the answer you have got. When you have diodes connected in this fashion like this, always better to. So I started with an assumption. So to conclude our assumption, we should find the currents through ordinary diode as well as Zener diode. So how to find those currents? Let me take this is ID1. What about ID1? Here the voltage at this point is 2.7 minus 0.7 by 1 kilo ohm. It is 2 milliampere. Okay. IZ, current through the Zener diode from cathode to anode, we need to find. We can't find it directly. What we can do, we can find this current I. I is equal to 3.75 minus 2.7 by 1 kilo ohm. It is equal to 1.05 milliampere. Means here if you observe, so I is equal to IZ plus ID1. So IZ is cathode to anode current from of Zener diode should be positive, and ID1 is also positive because it is a current flowing from anode to cathode of D2. If IZ and ID1 are positive, then I should be greater than any of these two currents. But I is looking less than ID1, which means we are getting IZ to be negative, implies IZ. Is it possible? Two positive quantities you added, result should be more than any one of the individuals. But here you are getting the result to be less than individuals. So something is fishy. So I minus ID1, which is negative, not possible. If Zener diode is under breakdown, cathode to anode current should be positive. Okay. If a diode is forward biased, anode to cathode current should be positive. Here, Zener diode under breakdown, cathode to anode current should be positive, but we are getting negative. Not possible means the Zener diode is not under breakdown. Okay. If so, what is the equivalent circuit then? Zener diode. So ID1, ID2, current through the diode D1 or D2. What did I write? D2, ID2. Okay, sorry. Let me take this as ID2. So the equivalent circuit, if you take so, Zener diode simply acts as open circuit. And instead of D2, I can write 0.7 volt, and this is the output. So how do we find the output then? Entire current will go like this. I can say this current is ID2. Okay, so V output is equal to ID2 into 1 kilo ohm plus 0.7 volts. What about ID2? It is 3.75 minus 0.7 by 1 kilo ohm plus 1 kilo ohm into 1K plus 0.7. So how much do we get? 3.05 3.05 by 2, that is 1.525 515. Okay, 525, correct, plus 0.7, 2.2525. Okay, this is our output actually. Anyway, if you look at the options, okay, option C is correct. 2.2, 2.2525 we have got. Okay, this is how we can do this problem. So it's not like both are conducting means we can take it as a default uh, condition, right? We are assuming that both are conducting, but every time we should conclude whether our assumption is right or wrong, right? After the assumption, we got some output equation. Don't stick to this as our final answer. We should cross check the currents through the diodes. Once they are coming to according to the convention, then only we can take that as answer. Otherwise, you have to change the decision. Okay. See the same problem, but instead of 1K, here I kept 2K. As I kept 2K, this current value, ID2 value will be less than what it was earlier. So that ID1 plus ID2 may be equal to I. Let us check it. Procedure remains the same. Okay. Assume D1 and D2. Okay, here as the supply voltage is greater than breakdown voltage, D1 is under breakdown and D2 is forward biased. Assume Zener diode is under breakdown and D2, GNR diode in the sense, otherwise D1. D1 is under GNR breakdown and D2 is forward biased. So we output. So as it is under breakdown, what is the output? It is equal to VZ, it is equal to 2.7 volt. The procedure remains the same. Then what about ID2? It is 2.7 minus 0.7 by, earlier it is 1K, now it is 2K. So 2 by 2, 1 milliampere. Then what about I? The current I is equal to 3.75 minus 2.7 by 1 kilo ohm, 1.05 milliampere. These two values are not changing. What about IZ then? IZ is equal to, yes, IZ is positive, ID2 is positive, IZ plus ID2 is I, which is greater than IZ or ID1, right? So anyway, IZ is equal to I minus ID2. It is 0.05 milliampere. That's it. Yes, everything is fine. Okay, that's what we have been doing every time. Okay, look at the processor. I never change the processor. I try to develop a processor which you can take it as a universal processor as far as that particular topic is concerned. 99% of the problems can be solved with that processor. Okay, that's it.